Lesson 18.1, Task 3. Find conditional probabilities from a formula. You do not have to create a table to find conditional probabilities. Instead, you can use a formula. All right, and a formula is good because if you know how to use the formula, then you can just plug numbers in and usually get the answer. So here's the formula for conditional probability. The conditional probability of A given B, that is the probability that event occurs given that event B occurs, is as follows. All right, so you got the probability of A, B, that's your conditional probability, equals the probability of A union B over the probability of B. A standard number cube is rolled and the resulting number is odd. Consider the probability that the number rolled is also greater than or equal to 3. All right, when rolling an odd number, the probability that the number rolled is also greater than or equal to 3 is conditional probability. What is event B, which is assumed to have occurred? What is event A? All right, so event B would be that it's an odd number. And event A would be that it's greater than or equal to 3. All right, and that comes from the given information here. All right, so it says the numbers on a standard number cube are 1 through 6. The set of odd numbers are, so odd numbers would be 1, 3, and 5. The set of numbers greater than or equal to 3 would be 4, 5, and 6. Wait a minute, greater than or equal to 3, so 3 would be included here. The set of numbers that is both odd and greater than or equal to 3. So the numbers that are both odd and greater than or equal to 3 would be 3 and 5. Because that's called conditional, so one happens if the other happens. I don't know what's showing up here. Something's messed up with the program, I guess. All right, so let's move on to the next one. It says, therefore, N of S equals 6. So that means there's a number of sides on the number cube. So there's 6 sides. N of B, number of B happening was 3. If we go up here and we see odd was, B was odd numbers, and there's 1, 2, 3, so that's why there's 3 is the number in set B, and the number in A intersection B is 2. So you can see where these two overlap when it both occurs, that's the 2 right here. So it says the probability of A intersect B is, it's going to be 2 out of your total number of 6. 2 out of 6 is 1/3. And then the probability of B, the number in B is 3. And again, it's 3 out of 6. So that's 1/2. All right, so if we use the formula, you can see that all we have to do is plug in the numbers. So basically, we're going to have, let's see if I can get my pencil here. So 2 over 6 is the same as 1/3 that we put above. And if you divide that by the 3/6, which is the 1/2, to simplify this, you're simply going to multiply by the reciprocal of the one on the bottom. So this is just like from elementary school when you had to learn about fractions. So I know everybody remembers that, right? All right, so 2/3 would be the probability of that. So does that make sense? Yes, that does make sense. All right, that's all for task 3. If you have any questions, let me know. Lesson 18.1, task 4. Find conditional probabilities. You can find conditional probabilities using frequency tables, relative frequency tables, and the conditional probability formula. A teacher surveyed all 128 of her students anonymously about an exam they took mid-semester. Let event A be pass the exam, event B did not pass the exam, event C studied 3 hours or less, and event D studied more than 3 hours. All right, so use a frequency table. The results of the survey are shown in the frequency table. So you can see here's the passed exam, did not pass the exam, studied 3 hours or less, studied more than 3 hours, and the totals 128 students. How could you find the totals of each row and column if they were not given? All right, so you'd simply add these numbers up to get this, and you would add these up to get this. So this one says you add the entries, subtract, multiply, divide. So we definitely would add the entries to get those. All right, what is the probability that a student who passed the exam studied more than 3 hours? All right, studied more than 3 hours. All right, you can see here in the table that is 59, and you can see there are 92 total that passed the exam. So 59 divided by 92 is the 64% that they're showing here. It says, why is this probability P of D A and not P of A D? All right, so P of D A is the probability of event D. Event D, remember, was studied more than 3 hours, will be true given event A. And event A was pass the exam. All right, so P of AD is kind of in reverse. So that's the probability of event A, meaning they pass the exam. And that will be true given event D, they studied more than 3 hours. So it really comes to which number you're putting in which position, whether it's the numerator or denominator, and that would definitely make sense. Remember, these are not commutative, so the order does matter for probability. All right, so use a relative frequency table. Create a relative frequency table. So they took the numbers above and they divided each by the total, and they got these percentages here. So 26% passed the exam who studied 3 hours or less. 46% passed the exam if they studied 3 hours or more, and that gives us 72% passed the exam altogether. All right, and then these are did not pass, and then of course you have your totals there. So it says, how are the values in the relative frequency table determined? So how are these numbers determined? Remember, each number, so you take the number and divide by the whole. So like this number here divided by 128, and that gives that percent. This number divided by 128, and that'll give that percent. This number divided by the total gives that one, and this one divided by that gives that percent. So here you're going to divide each by the total. So it says divide each value in the frequency table by 2, multiply the value in the frequency table by 128, divide each by 100, divide each value by 128, the total number of students. So that's it, because there were a total of 128 students that were given the survey or asked whether they studied to pass the exam or not. All right, so what is the probability that a student who studied more than 3 hours passed the exam? All right, so we're going to look at the probability of A and D. So studied 3 hours or more and passed the exam. So this is passed the exam, and this is studied 3 hours or more. So all they did was divide those numbers. Oh, wait a minute. I went studied 3 hours or more. The 53% comes from here. Okay, I was going to say that didn't look right. So 46% divided by 53%. All of this row studied 3 hours or more. So that gives you that 87% of the students who studied 3 hours or more did pass the exam. So that means studying for their exam paid off. All right, so why is the denominator P of D and not P of A? All right, so remember from before, D is studied more than 3 hours. All right, so the conditional probability formula is uses the event that already occurs as the denominator. The event that is assumed to have occurred is event D, which is a student studies more than 3 hours. All right. Use a formula. What is the probability that a student who did not pass the exam studied 3 hours or less? All right, studied 3 hours or less. The probability of a student who did not pass the exam. Okay, a student that did not pass the exam studied 3 hours or less. So that would be 0.21 over 0.28. Let's see what that is. 0.21 divided by 0.28. And that's going to be 75%, which is what they have. They've just used the numbers from the frequency table instead of the relative frequency table, but you're going to get the same thing because we just divided those two numbers. All right, that is all for task 4. If you have any questions, let me know.